in Africa, we never saw that. Even being prepared by the best professors, I was not able to touch a pipette. So after that, when I returned to Mozambique, I had a very difficult time to deal with that. But I decided at that time that I need to do something better.
This is Immuno Africa, a podcast dedicated to spotlighting African immunology research. Here, we amplify the stories of Africans researching the immune system to tackle the continent's growing burden of infectious and non-communicable diseases. I am Wealth Okete, a biochemist and science communicator in Nigeria keenly interested in research on immune system. On Immuno Africa, I explore and communicate research through the eyes and lips of Africans who do them. Whether you are a seasoned immunologist, a burgeoning researcher, or even an untrained person, I hope the time you spent here rewards you remarkably. Enjoy.
Professor Raquel Matavele Chissumba heads the Endemic Diseases with High Sanitary Impact program at Mozambique's National Institute of Health. In this role, she studies various diseases endemic to her home country, including HIV, tuberculosis, HTLV, which we will learn about soon, and more recently, COVID-19, especially in the context of regulatory T cells. As a young girl, she participated in science and mathematics competitions, some of which saw her clinching medals. Although these competitions reinforced her interest in science, they also helped her to come to terms with the challenges unique to the resource-limited setting of Africa. Now a professor of immunology, she is working hard to surmount some of these challenges by exploring ways to help the continent understand and meet its own needs. How is she doing this?
My name is Raquel Matavele Chissumba. I am a biologist and with passion in immunology. I'm from Mozambique. Since my early childhood, I always had passion with science. My inspiration was based on the cartoons or TV programs that we watched. During my childhood, I always tried to understand or to have a better understanding how the nature works, how we interact with the nature. And I was also very competitive when I was young. And my competitive journey started when I was at grade 4, when I decided to participate in a mathematics Olympiad at school. At that time, I think that I was in the 4th position. And then when I was at grade 11, I also participated in the National Olympiad of Mathematics. And I succeeded in that Olympiad as not as in a first position. I was in the 2nd position, and being the only girl, I had the chance to represent the country in a Pan-African Mathematics Olympiad in South Africa. Although the results there were not so good, but I always liked to challenge myself. And at grade 12, I also participated in Biology Olympiad in country, and I succeeded also, and I also had the chance to represent the country in International Biology Olympiad. I always like to work in science. I always like to be competitive and try to do my best. And during the last 2 Olympiads that I participated, especially the Biology Olympiad, during that period, we were trained with professors from the university. And I had a chance to learn a lot of things during that process. I think that we were trained during, let's say, more than a year for the International Olympiad. And when we went to Riga is a country that now is independent, was part of Russia, but is an independent country. When we went there, I never forgot the experience that I had there, because I think that we as Mozambicans, we were on the lower positions, and we felt really, really, really bad. because what I saw there, the technology that the other kids were very familiar with, we in Africa, we never saw that. Even being prepared by the best professors, I was not able to touch a pipette. So after that, when I returned to Mozambique, I had a very difficult time to deal with that. But I decided at that time that I need to do something better.
In a quest to do something better, Professor Raquel got into the university to study biology for her first degree. This decision positioned her to get the skills and experiences she needed to address some of the challenges in Mozambique and no doubt Africa.
I was admitted to do the biology course because it was the course of my choice. And I learned that the course that I really wanted to do was biology. It was during that time that I was training by these professors for that Olympiad. After getting to the university, yes, I finished my studies. And then after finish that, I had a chance to join a very good team at National Institute of Health at Department of Immunology, where I meet my professor, Dr. Ilesh Jani. And I joined to the INS team there. I start my journey implementing the CD4 count testing across the country. This was my first interaction with immunology technically. And then after that, I had the chance to do a master training within a collaboration between the National Institute of Health and a Brazilian institution that is called Instituto Oswaldo Cruz, or Fiocruz. And I had the chance to meet very good professors that are my mentors until today, Professor Savino, Professor Suzy. And during that time, I finished my master course with a dissertation on regulatory T cells in individuals with HIV, but co-infected with HTLV.
By the way, HTLV stands for Human T Lymphotropic Virus, but I don't know much else about it. So she pauses here to talk more about HTLV.
HTLV is a retrovirus that causes leukemia, actually. It is a retrovirus that is very similar to HIV. Actually, in the beginnings, in the earlier research of HIV was confounded with HTLV. Initially, okay. HIV was called as HTLV3 because there is HTLV1, HTLV2, and HIV was called HTLV3.
Oh,
so it's
okay.
very similar to HIV, but it causes cancer into a cell. So this virus has HIV, they infect preferentially CD40 cells.
Oh.
But when the cells are infected by HTLV, so this the HTLV immortalize the cell. So the CD4 they expand.
Yeah.
But these cells are not functional.
Before proceeding to talk about a PhD and how it also prepared her for better.
In 2014, I started officially my PhD, being supervised by Professor Luc from the University of Antwerp, and that within a collaboration between the National Institute of Health in Mozambique and the Belgian institution called ITM, Institute of Tropical Medicine. And during that time, in Mozambique, we had two studies that I was coordinating, the laboratory aspect or the laboratory part of that study. One of them was a phase 2 HIV vaccine trial, and the other was a study that aimed to prepare a cohort for a phase 3 HIV vaccine trial. I used the data or the cells from the participants of the studies to do my PhD project. And I defended with a topic on regulatory T cells in context of HIV early infection and in the context of HIV vaccine. So this was how I finished my PhD work.
You've been mentioning Tregs, you've been mentioning regulatory T cells. So I think we should delve into that aspect of your work. So you're going to tell us what regulatory T cells are and what they do in the immune system, why they are important, what could go wrong with them.
So usually when we talk about the immune response, the first image of the immune system that we have is that of cells fighting against a disease or antibodies that are fighting against one infection. This is the first or the natural image that we have of the immune system. But this is one part of the immune system. One of the ways that the immune system we use to control an infection or a disease is killing cells. So we have the CD8 T cells, we have the NK cells, we have the macrophage that engulf other cells. So the killing of other cells produce the production of toxic molecules is one of the way that the immune system use to control the infection. Is the main ways. There are other ways, but there is other side. If we keep producing these molecules that are toxic, they can also damage our cells. They will not damage only the cells that are infected, they will also damage healthy cells. So that's why in the immune system we have several regulatory mechanisms, and Tregs are one of the mechanisms that the immune system has to control the production of toxic substance, the activity of cells that are killing other cells. So these are the regulatory T cells that has the function to make the balance in the immune response in order to say is enough. The pathogen was cleared. Now it's time to rest. We have to stop. They come as the regulators. So these are the regulatory T cells. There are several cells with this regulatory capacity, but the main group of cells, or the well described, are the regulatory T cells from the CD4 T cell population, the classic regulatory T cells that are CD4 T cells, but with this ability to control the action of other CD4 T cells or other cells of the immune response. And they can act in different ways. They can secrete anti-inflammatory cytokines like TGF-beta, like IL-10. They can also suppress the immune response by sending like perforins and granzymes into the activated cells. So they have several ways of action to control the activity of the other cells or other elements of the immune response. Yeah.
So what are the things that could go wrong with this class of T cells, and the implications of those of malfunction in this class of T cells?
Yes. As I mentioned when I was talking about HTLV, that we had individuals with a very high number of regulatory T cells. They develop leukemia, they develop cancer. So if we have an environment that is highly suppressed, our cells will not be able to fight against disease. They need to have a room to fight against any kind of diseases. If Tregs are excessively activated are excessively acting in terms of number or the capacity that they have, if they are not well regulated, they can also cause disease. As I said, the classic example that I give was in case of HTLV, that they cause leukemia. So we have been seeing in many cancers that regulatory T cells are there. So in the environment of the cancer cells, we have several regulatory T cells. So the cancers, they I don't know what is the cause, but well, let's say that the cancers, they try to escape by the immune responses being in a way that is covered but regulatory T cells. So this is the bad side of regulatory T cells.
Away from regulatory T cells, we delve into the meat of the conversation. What exact challenges is Professor Raquel tackling in Mozambique? And of course, in the context of Africa. We start with leukemia.
One of the problems that we have in the health sector in Mozambique is the case of leukemia. In general, the survival rate in individuals with cancer in general is very, very, very low. We have a very high mortality rate. And one of the factors that are associated with the low survival rate or higher mortality rate is the lack of tools to diagnose these individuals. Most of the times they arrive at the hospital at a very, very late stage, or the hospital has not tools to diagnose properly the cancers that the individual have. And in Mozambique, before that time, there was not a flow cytometry diagnosis for leukemia. So that was the challenge that I put to myself and tried to use the skills that I had during my training to support the public health system. And we introduced it with the help of the support of the Shy is how can I say is Clinton Foundation in Mozambique. They sponsored that activity, and currently we have a system and to diagnose leukemia.
And then COVID-19.
At the end of 2009 and early 2020 in Mozambique or in the world, we have the COVID problem. And at that time, I was also appointed to be the head of one of the programs, strategic programs at INS. That is the program of endemic diseases, I can say, all diseases with high sanitary impact. And we had the challenge of COVID. No one knows what to do. I was shocked, as everyone was shocked. And the borders were closed. We had a lot of shortage of suppliers. And as an institute, we had to try to find a solution or think into think in a very worst scenario of what would happen in Mozambique. And as you know, if we go back, when I told you the story of the biology Olympiad, when I went to
Riga,
to Riga, I was shocked because I was not able to hold an automatic pipette. I was not able to manage a gel. Was everything new. And again, we were in a kind of similar situation, but was in a situation that we need to find a solution here for a problem that we have. Because here in Africa, in general, particularly in Mozambique, I can talk about Mozambique, we have so many problems, and the main problem that we have is dependence. We do not produce nothing. Most of the products that we have, we rely on other countries to supply. And with COVID, we didn't know what will happen. We didn't know if we will have medicines to treat the people, if we would have tools for diagnosis. So even in our institute, we were requested to find solutions for the diagnosis. We were stressed to think, and at that time, I even a little bit before the COVID, I established collaboration with friends of mine in other areas, and we were trying to produce medicines, or try to make the better use of the plants that we have to treat several diseases. And at that point, when the COVID came, I said, no, I think that I have to hold on that idea that we had with my friends. Let's try to find a plant or plants that can help us to treat COVID if we get in a situation that we have nothing to treat our population. So I was researching at that time plants because my background was on control of exacerbated immune response. So I was a little bit prepared to understand the COVID disease, because COVID was basically a disease, or is basically a disease that we have an aberrant immune response. And as my PhD and my master thesis was on Tregs, that are cells that controls exacerbated immune response.
Yeah.
So I was trying to look into plants that have ability to modulate our immune system in order to control the inflammation. And with friends, we identified some plants. One of them was moringa, that was well documented as a plant that is used to treat diabetes. And this was the first one candidate plant to be tested. And we didn't have funds, but at that time we tried to apply for a UNESCO grant, actually OWSD grant, and that is part of UNESCO. And I was one of my project was one of the selected projects, and currently we are still testing. Not only moringa, but other plants. But again, we failed again. I feel that we failed again because we were not able to respond promptly. Until now, I'm still testing, but COVID is almost, I will not say that it's done, but we are not in the same situation because we were completely dependent of other countries, even to have reagents to test what we want to do. Mm-hmm. So this is the big challenge. I will start to say that we have as Africa. We are still testing because the main objective for us is just to create a base that we can use to test other plants, and if we have other outbreak, other pandemic, we'll be more prepared to face it.
You mentioned, and when you're talking about COVID-19 and how that some of the symptoms of the disease were related to an aberrant immune response. So the immune response overworking itself, or doing so much, and that ends up kind of affecting some of our cells. And you also talked about like we're working on certain herbal remedies that could modulate the immune response. So I want to ask, the remedies you're working on, the plants you've identified, or the ones you're still trying to identify, are they by any way working through these regulatory T cells?
Well, I cannot answer you right now, but we are testing that maybe one of the but one before going that, maybe try to go into another topic that is really, I will go there, but I think that is important. And that we have found that because we are talking about Africa here, most of the literature that we have so far is based on studies that were conducted in a different environment in different countries, especially Western countries. And there is a few studies that we have that are conducted in our settings here. One of the things that we are doing on that project, beside of studying the plants itself, if they work or not, we are also trying to understand the course of the disease here in Africa, in this case in Mozambique or in Maputo. We're trying to understand how COVID disease is in African context, in Mozambican context. And so far we are seeing few difference in terms of, for instance, this is a work that we will present in a few weeks in a conference. We are finding, for instance, the literature say that individuals with severe disease, they have higher production of IL-6. They have higher production of TNF alpha. They have higher production of IL-1. We are not seeing it in our patients. We are not seeing it. We are seeing that they have a different profile. We are finding other cytokines that are associated to severity to diseases in our context. This is one thing that is important to us to understand how the disease manifests in our environment, because we are in a completely different environment. We know that immune system is modulated by the experience that we have throughout our life, by the environment that we have, by the microbiome that we have, but by what we eat, but the disease that we had. So this makes us, or makes every community single. So we need to understand how the disease manifests here in our context. This is one thing that we are doing. Going back to the question that you did related to Tregs, we don't know exactly if the plants will modulate Tregs. Actually, as I say, I don't know if Tregs are relevant in our setting. We need to understand first how the disease is manifested in our setting to be able to propose something that is applicable to the course that the disease take in our setting. So that's why I cannot, we don't know. Well, we don't know if they will work on Tregs, but we are not expecting only that. We expect that they will act into the indicators of the disease that we will find in our population. I don't know if you were able to get my point.
Yeah, I think I get your point. So I think really you're saying that COVID manifests pretty differently in Africa from what has been observed in other countries or other continents. So it's important that we, understand COVID in our context.
Yes, in our context.
Yes. And also, whether regulatory T cells are playing a role or not will be determined by, the understanding we get from that context. Yeah.
Yes.
So you just mentioned that regards the role of regulatory T cells in the mechanism by which these plants would modulate or regulate the immune response. That has not been confirmed. You've not confirmed that. And then because Africa has a different, manifestation, has a different response to the disease. So there's still lots of work and studies to be done in that regard. So
Yes,
I'm
we are
basically
doing.
yeah.
Yes.
So I'm basically asking about the plants that you've identified, about whether or not you've tested them on individuals with COVID, and what were the responses you got. So you've been mentioning several cytokines that could be playing a role in the manifestation of COVID, and also maybe with regards to suppression of the immune system. So what were your observations when you tried these plants on people who had COVID? So that's my question.
Okay. Well, first of all, just to have try to explain exactly, or have a more try to give a more clear vision of what we are doing. We are doing in vitro studies to test the plants, but these are plants that some of them, in case of moringa, the identification was based on the literature. But the other plants that we are studying were identified based on local knowledge, because we have I don't know the name in English, but that I think that is called traditional healers. Yes.
Okay.
We identified the cells based on the local knowledge. Because here in Africa, in Mozambique, I have most of the majority of the population, they prefer first to go to the local solutions before going to the classic treatment or the classic medicine. And we learn a lot when we get information with these traditional healers. So in our study, part of the study we interviewed the local healers to know what are the plants that they are using to treat COVID or treat diseases with symptoms similar to COVID, and we got these plants. So we are not working with people that consumed these plants. We are not conducting a clinical trial. What we are doing, we collected samples from individuals with COVID, but with different presentations, individuals that are asymptomatic, individuals with mild symptoms, individuals with moderate symptoms, and individuals with severe symptoms. So, and we are using the PBMCs, the peripheral blood mononuclear cells from these individuals, to do the experiments with the extracts of these plants that are being used in the community. So basically what we do several experiments, and part of the experiments is that we take the cells from individuals, for instance, with severe symptoms, and then we challenge them with COVID antigens in the presence or absence of these plants, to see if the production of the chemokines in response to COVID will be suppressed by these plants that we are using. And in parallel, we are also comparing, we are using as control regular immunosuppressors, for instance, like dexamethasone. We are trying to compare the effect of this plant using as a control a regular medicine that is using the classic medicine, to compare with these plants that are being used in the community.
Okay. So sorry, I just want to get clarify something. The samples you're working for your studies, like the cell samples you're working, or the blood cells, are they from individuals who are already infected with COVID, or they are from individuals without COVID? They are from individuals with COVID.
Yes, we have individuals without, but our goal is to study in individuals with COVID. because we want to see if you get COVID, if we can use this plant to control the inflammation or not. And we are comparing the effect of these plants with the effect of a classic medicine. Yes.
Okay. So, what has been your findings so far? Are there findings that you can share, or they've not been published?
No, so far we don't. At this time, we don't have nothing to share yet. Okay. But I promise that once we have the results, if you allow me, we will be able to share in this platform.
Yeah, sure. It will be an honor to host you again to come share the findings. Yeah, so thank you so much. I think we've talked a lot about leukemia in the context of HTLV. That's I think human T lymphotropic virus or so. Then we've also talked about your work on COVID-19 and testing potential herbal remedies to that could be useful in the treatment of COVID-19, and not just COVID-19, but perhaps
other inflammatory diseases. Yes. Because what we want is just to create, because as I said, we have a very big challenge here in Africa. We don't have the resource. We have to try to use the resource that we have in abundance. We have plants, we have our knowledge. What we have to do now is try to calibrate our knowledge and try to use the appropriate dose, try to see if it works. How can we? Yes, it's what we are trying to do, but we are trying to prove it scientifically. Yes, so I think that as Africa, we should invest in our knowledge. We have to invest in what we know and try to see if we can resolve our problems based on our knowledge.
As we drew the conversation to a close, I asked Professor Raquel to share her opinions on cartoons in the present day, especially because she mentioned earlier on that the cartoons she watched as a child contributed to her taking interest in science.
Well, yeah, this is a very challenging question. Well, I would say that yes, I think that today we cannot compare what we have today and what I had when I was a child. Today we have a lot of information, we have a lot of resource. Children, they have the access. I think that today we have more. We are how can I say, we are bombarded. We receive a lot of information. Children have a lot of information. So this is our responsibility as parents to try to make the best use of the information that they have in order to make them to grow up as individuals that they know where they come from, what are the problems that they have, and try to use this to solve the problems that they have in their context. In general, we have a lot of information, but maybe because we have too much information, we lose the focus. But I don't like to be, how can I say, pessimist.
Yeah.
Well, I believe that with the information, with the resources that we have today, we are in a better condition to have a better world to our children.
Thank you so much for your time. So I don't know, you have final words to share regards your work, regards science generally in Africa. There's this context of your work about the need to, strengthen African capacity to conduct research, strengthen African capacity for independence, especially in the context of your country, Mozambique. Like, okay, we are importing so much, we are importing drugs, importing reagents, importing virtually everything. So how can we create something that is relevant to our own context? So there's this less reliance on the global north. So
Okay. Well, thank you, for that opportunity. Well, I will say that first, we need to believe in ourselves. We need to believe that we can do the things. I think that this is the first step. And we should put ourselves as the main players. Most of the times, we blame the government, we blame X. Yes, it's possible, but we cannot expect the government to resolve the problems that the scientists needs to solve. So I think that us as a scientist, we have a role, and based on what we learned during our training, I think that we should, this is the exercise that I'm trying to do, I'm doing day after day, is try to use the resource that we have, the limited resource that we have, the limited knowledge that we have, and try to use it to create solutions. And we have to believe that we can do that. We don't need to do in the same way as our brothers from the other countries that have more resources they are doing. We have to try to do it in our way. We have to know that we have limitations, we have the problems that we have, but we need to be part of the solution, and the solution needs to start with us. And we can do that. We can do the things in our way, in our setting, in the African manner. So this is the main message that I leave to the other scientists, and we need to unite ourselves. We need to stay together. Because myself, Raquel, I cannot resolve all the problems. But if I have a friend that is chemist, if I have a friend that is nanotechnology, maybe together we can do something that is much bigger, much beautiful, and we can resolve a bigger problem. So we have to believe in ourselves, and I'm sure that we can do the things in our way. That's my message.
You wouldn't hear Professor Raquel speak and not want to start having faith again in our continent. And if most of us, like her, can think of ways to nurture the limited resources at our disposal to surmount the myriad hurdles we face in our local settings, we will someday build the Africa we can be proud of.
Thank you for listening to this episode on Immuno-Africa. If you enjoyed it, please feel free to share it with your network. You will learn first about future episodes and get other immunology-related updates by following Immuno_Africa or the Immunology in Africa podcast on social media. See you on the next episode. Bye.